Welcome back to our EOC review. Today we're going to be talking about exponents and polynomials. We're going to start by talking about the properties of exponents. So power of a power means that you're multiplying like bases. So what you do is you add the exponents. So here it would be a to the x plus y. But what that looks like over here is that you would be saying, when you say x to the 8th times x squared, you're actually just going to add those exponents. So you're going to say x to the 8 plus 2. So that's x to the 10th power. So we're going to say add exponents here so we don't forget. And then power of a power. So this is when you're taking it and you're raising it to the power. So you actually multiply these. So this would be a to the xy power, or x times y. So you multiply exponents. So what that looks like here is that we would say 8 times 2. So we would get 16. So x 8 times 2. Quotient of power. So if you're dividing like bases, you just subtract the exponents. So you got a to the x divided by a to the y, so you would have a to the x minus y. So in this case, we would say 8 minus 2, and so we'd have x to the 6th power. Negative exponents, okay? So this is when we're going to use reciprocals. We've said that word a lot lately, reciprocals. So you're going to take it and you're going to flip it. So remember that this would be a over 1. We're going to make it 1 over a and then just change that exponent to a positive. So here, this is x to the negative 8, but instead, we're going to say 1 over x to the positive 8. Okay? 0 power. Any number to the 0 power is 1. Doesn't matter if it's 1,229 to the 0 power, you're going to get 1. Every time. So 8 to the 0 power is 1. And then rational exponents. So when you have these, when you are taking the rational exponents, so it's a to a fraction, right? You take the numerator and that becomes, it's a to the x power. Whatever that numerator is going to go inside. And on the outside will be your root. So however many you're taking, like a square root. So for this one, 8 to the 1/2 power would be the square root of 8. Our numerator is 1. So we really don't have to say 8 to the 1st power, but this is what it would look like. And square root usually means, well, it does mean 2. So this is, so you really could just write it as square root of 8. Okay. When we are adding and subtracting polynomials, the first thing that we have to do is identify the like terms and add their coefficients. So we're just simplifying the expression, okay? You're going to rewrite subtraction problems as addition by adding the opposite, okay? And I'll show you what I mean. All right. So we're going to say 8x squared plus 10, and we want to subtract negative 8x squared plus 13, which really what we're doing is we are multiplying negative 1 times negative 8x, and that gives me positive 8x squared, and negative 1 times 3 is negative 3, or we're just changing these signs. Do you see that? We just changed this sign and this sign. And now we add straight down. 8x squared plus 8x squared is 16x squared, and 10 minus 3 is positive 7. So that's my answer. If you're adding, you just combine like terms. For multiplication, this is, my computer is being a little weird. For multiplication, it says each term of the first polynomial is distributed to each term in the second. Combine any like terms to simplify. I'm going to be honest with you. I like the graphic organizer method. The box method is what I call it. That's the one that I prefer to use. I'm going to do both of these examples for you. But if somebody were to ask me which one is my favorite, I would definitely say the box method. So x minus 5 goes across the top, and x plus 3 goes here. So you keep those signs with it. So since this was minus 5, it becomes a negative 5 here. X times x is what's going to go. So you're going to say x times x here, and that makes x squared. And then you're going to say x times negative 5 to go in this box here, and that gives you negative 5x. And then 3 times x is 3x, and 3 times negative 5 is negative 15. So now what you have to do is combine those like terms in the middle, and they're always going to be like terms in the middle. So it's sort of like you take a z and you write down the answer in a z form. So x squared, then we're going to combine those middle terms. So negative 5x plus 3x is negative 2x, and then minus 15 there at the end. Okay? So in example 2, they're using FOIL. So you say first, outer, inner, last. So first is 2x. Oops, sorry, that was wrong. 2x times x is going to be the first terms in each binomial there. So 2x times 2x is 2x squared. I'm sorry, 2x times x is 2x squared. Then 2x times negative 7, because that's your outer, right? 2x and times negative 7 is negative 14x. Then we're going to do our inner two terms, which is 5 times x, so that's plus 5x. And then you do your last. 5 times negative 7 is negative 35. And again, you have those middle terms that you have to combine. So we have 2x squared. Negative 14x plus 5x is going to give me negative 9x, and then minus 35. And that's my answer there. Okay, so you've got some special products where it says square of a sum. And that is always going to give you a squared plus 2ab plus b squared. Okay, so if you have x plus 2 squared, that's really x plus 2 times x plus 2, you're going to get, so a squared would be this first one, so x squared, 2ab, so 2x is ab, but if we need 2 of those, that would be 4x, and then 2 times 2 would be b squared, which is 4, so that's your answer. Honestly, I think it's easier to just work it out and use the box method. For difference of two squares, difference of a square, square of a difference, oh my goodness, square of a difference is a squared minus 2ab plus b squared. So similar thing, except you have this negative sign, so that's why the 2ab becomes negative in that one. So the same kind of example here, you would end up getting x squared minus 4x plus 4. So that's the only difference, is that you would have minus 4x instead of plus 4x. And then difference of two squares, which is what I thought we were talking about, it's just a squared minus b squared. So if this was x plus 2 times x minus 2, it would just be x squared minus 4. Okay. All right. Now we're going to talk about dividing polynomials. So it says divide the dividend by the first term of the divider. That's a lot of vocabulary words there. So dividend is the number that we are dividing, and the divisor is the number that we are dividing into. So this would be our divisor here. This would be our dividend on the top. Multiply the divisor by that term. And then we're going to subtract and bring down the next term. So what we're going to do is set this up like a long division problem. So we've got x squared plus 4x. That's what we're dividing into, and x is what we're dividing by. So x squared divided by x gives me x. And now what they're telling you is the next step would be to multiply. So we'd say x times x is x squared. And we're going to subtract that. So now all that's left, x squared minus x squared cancels out, and we're left with 4x. So then we're going to say 4x divided by x is 4. And it's a positive 4, so we'd say plus 4. 4 times x is 4x. When we subtract that, we're left with 0, which means that we're done. So our answer to that division problem would be x plus 4.